Well, good morning, everybody. Welcome to Java 1, and welcome to our session about mixing OSGi and Java EE, or as we titled it, about modular Java EE in the cloud, and a practical guide to mixing Java EE and OSGi. So, interesting topic. Before we dive into the content for this 2-hour tutorial, just want to briefly introduce ourselves. To my left, there is Paul Bakker. He is an architect at Luminous Technologies, which is the R&D department of our company in the Netherlands. Paul is working on the Amdatu open source cloud platform. We will show you a little bit about that later on in the presentation. And myself, I'm working in the services department of Luminous. I'm mostly doing customer projects. I have some internal responsibilities as well. And besides my day job, I'm also a Java user group leader for the Netherlands Java user group, which is a Java user group of about 3,500 people. And I'm also a Java champion. If you want to reach out to us, feel free to do so on Twitter. And one of the last slides of the presentation, I have some other contact information for you as well, including our email addresses and stuff like that. So just to kick off this tutorial, we want to do like a brief presentation, and then we do mostly live coding. So Paul will do all of the live coding, I will do most of the talking. And just to get us started, I want to do some observations, some trends first. So one of the things we are seeing today is that applications that we are building now are tending to grow bigger, more complex, trying to solve more difficult problems, and in order to do so, the applications that we build, they grow bigger, and we put more stuff into it, more frameworks, stuff like that. On the other hand, we have a tendency to use more and more agile methodologies to develop our applications. So we use things like Scrum or XP or other agile methodologies in order to come up with a solution for our customers' problems, right? So what we learn in those methodologies is that we need to break up our complex problems into smaller parts and then start building solutions for the smaller parts. And then, well, you cannot design everything up front, at least that's what those methodologies say. So you just start off doing some stuff, and then later on you reconsider, you do some refactoring, you reconsider some of your architectural decisions, not all of them, but some of them, which leads to an interesting development process in which stuff that you have built like 1 or 2 months ago needs to be refactored, and some architectural decisions that you made 1 or 2 months ago need to be reconsidered, right? So if you compare it to building, for example, some construction thing like a skyscraper, right? It's really hard to imagine building like 20 floors and then refactoring the base of the skyscraper, right? That's going to lead to interesting challenges. So in software development, well, we kind of have the same problem if you do not pick the right approach for that. So there's some design up front, and there's some architectural decisions that you have to make up front, but some of those decisions only come when you understand the requirements better, right? So on the one hand, we're building bigger, more complex applications. On the other hand, we have an interesting way of doing so using a iterative, agile approach. So this gives us a number of challenges, and they are not unique to just building agile applications, but they are the challenges that we are facing today. So, of course, there's the challenge of dependency management, right? We are using all sorts of frameworks from the internet, open source frameworks, maybe frameworks that we build ourselves. And not only external dependencies, but also dependencies of modules in our own application. Like one part of our application is dependent on another part of our application, and there are some dependencies between those parts, and those dependencies have to be managed. When you're building them at first, everything just works out fine. Then after like 1 or 2 months of refactoring, or if the application is in production and you need to do some fixing or maintenance on it, then dependency management starts to get more and more interesting. Let's put it that way. Then, well, next to dependency management, there's also the problem of versioning, right? Versioning at first is also not a problem because you're building version, 0.1 or 1.0. And as long as you're building 1.0, nothing really is the matter with it, right? But as soon as some parts of your application start changing more rapidly than others, then you have versioning issues within your application. And also if you're facing external clients or if you have external interfaces with other applications, then versioning is getting more and more interesting because having multiple versions of the same functionality of your application up at the same time, that's going to lead to interesting things that you should have a solution for. Then there's the maintenance thing. And maintenance is something that we always think about a little bit too late because we start thinking about maintenance as soon as the first fixes have to be done, right? So if we are building an application of which we know that it will have to be in production for 10 to 15 years, which is not really strange, then you have to think with maintenance in mind from an earlier point than, let's say, after the application is running for 5 years in production, right? So if you want to do long-term maintenance, you have to come up with some design constructs in order to be able to cope with maintenance, especially in combination with things like dependency management and versioning. And then the last thing is deployment. Deployment in the cloud is, of course, an interesting issue, because what are you going to deploy? Are you going to deploy your entire application all of the time, or do you just want to deploy smaller bits of your application which have actually changed or needed maintenance, right? So deployment is also getting more and more interesting, and the way in which we deploy in Java, like is it one artifact, or are we just deploying multiple smaller artifacts? This leads to some interesting challenges as well. Then the other trend that we see is that more and more applications that we build today are moving towards the cloud. Maybe the applications that you are building today are still on regular service, but well, in the next years or so, more and more applications will be deployed in the cloud. Which means that if we are building applications which have to last for like 10 or 15 years, maybe we're building it for a regular server now, but it has to be deployed in the cloud maybe in 1 or 2 years, right? So the cloud brings a whole new set of challenges, of which not all of them we are going to cover right here, but there's a number of them that I want to talk about, which are the non-trivial, non-functional requirements, right? I mean, cloud has an uptime of 24/7, so your application has an uptime of 24/7, so it's always someone's business hours anywhere in the world, right? So you have to deal with zero downtime deployments, for example, right? There are some tricks that you can do in order to achieve zero downtime deployments using clustering or stuff like that. But if you want to achieve real zero downtime deployments, especially in a complicated cloud infrastructure, then you need some tooling in order to be able to cope with that. Then the thing about modular deployments, I talked a little bit about it on the previous slide. If we are building an application for the cloud, and it's like an application, let's say it's about 500,000 lines of code, it's like maybe 20-30 megabytes of code and resources that you have to upload. And if you're working on that offsite, and then you have to upload that application to your cloud provider, that will take you a while, right? So uploading the entire application takes you a while, and then, well, when you start running it, well, maybe in production or in like a preview mode, and you say, okay, well, there's a small error in there, I need to fix it. Well, you change the code offsite, then you have to upload the entire application to your cloud provider again, right? So this will give you some interesting challenges. I mean, you don't want to upload everything just for some small change or small add-on that you do to the application, right? So chunking up the big executable that will be running in the cloud into smaller parts, that's also something that we need to deal with. And then as soon as we're building cloud applications, and especially goes for software as a service applications, then you, of course, start off at like a generic approach in which you can serve all your customers with. But then, you know, when this really interesting prospect customer signs up and it says, well, I want to be your customer, but then I need to have like, well, this special functionality in there just for me. And then after a while, the next really interesting customer shows up, which also needs a little bit of customization of your generic functionality. So you are running with multiple versions of your functionality in production just to serve your specific customers, right? So this will lead to maintenance nightmares if you don't do the right things. So this is actually the trends and the interesting problems that we need to deal with when we start building applications for the cloud age. So I can give you more problems, but actually the answer to all of the problems that I'm going to give you today is modularity. And if you've been to the Java 1 keynotes yesterday and you've paid attention, then you saw the word modularity on each other's, well, on like a lot of slides there, right? So modularity is actually like a hot thing. And there's this whole debate about Jigsaw being delayed and stuff like that, so we address that later on. So I want to talk about that as well. But modularity right now is a key thing in designing and running your applications. And that's exactly what we want to talk about today. And not only talk about it, we actually want to show you a lot of stuff about it and how you can do a pragmatic approach towards a modular enterprise application today. So the big question is, okay, I saw the word on every slide, but what exactly is modularity, right? So if I go back to what I learned about object-oriented design in university, I actually, to be honest, I just remember one thing, and most of us will probably remember it. So I remember about preventing tight coupling and promoting cohesion, right? Does that sound familiar to everybody? All right, this is what you learn in university, right? So what is tight coupling and what is cohesion? So I tried to draw a little picture on the right-hand side of the slide. And tight coupling are parts that, well, really belong together, right? They have strong dependencies on each other, and they are needed in order to solve like a smaller problem, which is in your application. And in order to do it in an object-oriented way, you just break your problem into smaller pieces, you start solving the smaller pieces, and some of those solutions to smaller pieces, they just belong together, right? They have a tight coupling because, well, you need like, you need all of them together in order to solve that small piece of complexity. So you have similar things in other parts of your applications. So you have like little tangled constructions of objects in your applications, and then you have like some chunks or blocks or lumps or modules, whatever you want to call them, that just group those tightly coupled classes together, and then between those lumps of a little bit of solutions, there's like a well-defined interface, and that well-defined interface, that's what we call cohesion, because those lumps are working together, but the internals of the lumps, well, they are just private to the lump itself, and they are not really interesting to have dependencies on directly from other parts of your applications, right? So this is like the in a nutshell a way to talk about preventing tight coupling and promoting cohesion, right? So this is basically what you should do in your design. So how do we prevent coupling in a code base? Right, so if you're writing your code today, or if you like you did yesterday or last week, how do you prevent tight coupling in your code base using Java? Anybody have a suggestion? Dependency injection, yes, or more specifically, you can use interfaces, right? So you separate contract and implementation. This is also some basic thing that we learned in school, right? So interfaces is a good way to start, separating your contract from your implementation. But the next question is, interfaces are nice, but how do you make sure that nobody accidentally accesses your implementation classes? I mean, you have interfaces in Java, public interfaces, you have public implementation classes, and those implementation classes are still public, right? So anybody with access to that package can just, well, new your class, and then they still have your implementation, right? So how do you prevent that? Obvious solution, implementation hiding. So you want the interfaces to be public, but the implementation to be private, right? And actually in Java, we don't have an airtight mechanism for doing that. Of course, we have private, protected, public keywords, but they just don't cut it. You need something else. So actually what you want to achieve is something which I tried to picture on this slide. So we want to have a thing which we call modules for now. So modules is like the magic word here. So, and they have like a public part, which is the top part of the module, which exposes some public things, mostly interfaces. And then they have like a private internal part in which the implementation classes reside, right? So the implementation classes, they implement, or they might implement the interfaces in the public part, but they are not accessible and not visible to other modules in our system. So if you look at this picture, you see 3 modules, A, B, and C, and you see that, for example, module B only has a public class, which might be an interface, and that there's a dependency between module A and B. So module A implements the public, module A imports the public part of module B, and then as soon as it wants to start using an implementation of class C, it needs something which implements that, right? So then there's module C in this picture, and module C also imports module B, and then it has some implementation, for example, for the public interface of class C. Now this is a nice picture, and in this picture we solve the implementation hiding thing. But how do you do that in Java, right? So how can we have like a module system like this in Java right now? We need more than just what the VM offers us today, and we need more than just public, private, and protected. So I'll talk about that a little bit later. Right. So how do we create an instance of such a hidden class? I mean, you cannot do something like my interface is new my implementation, because the my implementation class resides in a private part of another module, right? So you do not have access to that implementation class. So we need something for that. But one of the things which was actually just suggested, dependency injection, is a way to do that. And This is a drawing of a little bit more of an abstract way of doing dependency injection. It's actually like a man-in-the-middle approach or a service registry approach. You might recognize this from, for example, RMI. If you've ever built an RMI application, then you have something like a registry in which some parts of your application register implementations and other parts of your application do lookups of implementation classes. Now, this is sort of the same thing that we need if we want to solve the implementation problem. So we have like a man-in-the-middle, which is the service registry, and then we have a module A, which registers an implementation of some sort using the interface at the service registry. Right? And then other parts of your application, in this case module B, can do a lookup at the service registry and say, okay, I need something of this type, and this type being the interface. And then the service registry starts looking for it, and if it has an implementation, it just returns you the implementation. Or if you have a more advanced system, you can use notification. So as soon as module B has expressed interest in an implementation for my interface, then the service registry will supply it to him as soon as it got an implementation of such an interface class, right? So if you think about it a little bit, then dependency injection is sort of a similar mechanism in order to solve the same problem. So if you start thinking about doing real modularity in Java, then there's actually two ways where modularity really matters. We have modularity on design time, on architecture, at the time when you think about architecture and design of your application. So you have to, split up your complex problem into like multiple smaller parts. Like this is the story that I told you before when we talked about preventing tight coupling and promoting cohesion, right? So you're just thinking about what parts of functionality you want to solve in which parts of your application, and you try to design as nice a modular functional or technical design as possible. So this is actually the time that you just unleash all your design patterns, right? So you do divide and conquer. You try to force single responsibility, separation of concerns, all the design pattern buzzwords, right? So you try to come up with an architecture which is clean, prevents a spaghetti of all sorts of objects just having relations to all other parts of your application, leading to horrible design tangles and stuff like that. So this is what you do when you're designing things. And when you want to achieve modularity, we should not skip the part about all the effort that go into your design. Right? You should come up with as clean as a design as possible. Then the other thing is, there's also a thing about after you've designed such a really nice modular design, how do we run it in Java, right? So you come up with like the most beautiful modular design ever, and then you start writing your code, and then you package everything together in just a single WAR file, right? Okay, so there goes modularity, because we have just put everything in one big lump again, and nothing's modular anymore at runtime. So there's two sorts of modularity. There's design time modularity, and there's runtime modularity. So if we look at runtime modularity and we look at the Java platform, then there's actually a very nice vehicle for that already in the platform, which is the jar file. Because the jar file, it's a way of grouping classes and interfaces together. So you can have your beautiful designed lumps of code and just package them together in a jar file. Get another part of your design, package that together in a jar file as well. Same thing for the next part, etc. So instead of ending up with just a single WAR file, you're now ending up with, say, 100 jar files, right? And don't be scared by the number 100, because if you're building like a serious application, you will probably use, a really large number of jar files. I mean, depending on how big your application is, of course, but I mean, more jar files is not bad, as long as you have a great way to do dependency management and versioning, right? If you don't have that, that will eventually lead you to class path hell, and we all know that from the past. Right. So we talk about class path hell in a little bit. So next to having a way of packaging your beautiful designed and written classes, we also need a way of dealing with runtime dynamics. I mean, it's really nice that we now have all sorts of jar files, but how do we deal with implementations being there at one time and then not being there at another time, right? So how do we deal with versioning? How do we deal with dependency management? So we need a mechanism that gives us runtime dynamics. And the runtime dynamics are all about, how do we hook those different blocks that we just saw in my little picture, how do we hook them up at runtime, right? So in order to do that, we need three things. And I try to picture them out on this slide here. So first and foremost, we need an architectural focus on modularity first, right? So design is what matters first. So you have to have a modular design. So having an architectural focus on modularity has some design consequences, right? So your design, suffers on the principle of modularity, but eventually it will get better, right? Because you have better maintenance in the end, because you have everything split out, you don't have any ugly design tangles, so it's easier to do modifications, so it pays out at a later moment. Then the next thing you need is runtime modularity, so you need jar files, and you need a runtime module framework, or runtime dynamic module framework. And right now, OSGi is the only viable option to that, right? There's a number of approaches to doing a dynamic services framework, and once upon a time, Jigsaw was one of the options, but then Jigsaw is actually only about, cutting the Java runtime in smaller pieces, and it's not about providing you the runtime dynamic services framework that you need. So now that Jigsaw is being pushed back to Java SE 9, which means that it will take a while to get at least 2 to 3 years, then it still gives you only a way to chunk up, big implementation of the JDK, and it does not offer you a dynamic services runtime. So if you are waiting on Jigsaw to do modularity, you can wait at least for another 5, 6, 7, 8 years. Right? So don't wait on Jigsaw to do modularity. So right now we need to focus on OSGi because it's been around for a long time now, and we think, and we're going to show it to you actually, that it has become a lot easier to use the power of OSGi in order to build such applications. But let's not forget the last part of this slide, which says let's not reinvent the wheel. Because OSGi has a little bit of a reputation that you have this nice dynamic runtime, but then you're on your own. So you have to reinvent all your frameworks, you have to come up with everything yourself again. And that's not something that we want to do, because we have 17 years of Java, and we have 10 plus years of enterprise Java APIs, and for building enterprise applications, we are used to the power of the high-level APIs that we used to have, right? So, for example, EJBs or RESTful APIs or like web frameworks or stuff like that. We don't want to, end up with having just Java and then need to build everything ourselves. So we want to have both the power of the modular framework and the high-level enterprise APIs that we're used to. So this gives a little bit of an interesting ingredient into the mix as well. So once again, OSGi is what we think the de facto standard module system for Java. And OSGi is not the same as modularity. I just want to stress that point. So we are not strong OSGi evangelists in the way that we say, just do OSGi and everything will be all right. Right? So I want to just turn it around, say modularity is your key focus. So it's an architectural principle. And then OSGi is an excellent way of doing so. So what about Jigsaw? Well, we talked about Jigsaw. And once again, just to stress, modularity does not come for free with any framework. So using OSGi is no guarantee that you're doing modularity. So you have to still think about it. Right. So let me quit talking for a while and let Paul show you how easy it is to start off with building a modular application.
So when people start talking about OSGi, most people say, well, I really don't want to use OSGi because it's complex, the standard is too large, it's complicated, and in general just a pain in the ass to use because I have to think about my dependencies and it's a lot harder, I have to do all those imports and exports by hand and it's just so much work. Well, it's not, and I'm going to show you that. The reason that people think like that is because, they've been looking at the past when OSGi was around already, when there was no tooling at all yet and you had to do stuff by hand. Or they have been looking at writing Eclipse plugins, for example, which is based on OSGi, but not the best way to do OSGi. And that's really another way you should look at doing application development with OSGi. So what I'm going to show you is using the tools from today to just write modular applications. I'm going to start this demo with absolutely nothing. So we're just going to start building an application from scratch. And the first part of the demo is just basics. So we're going to look at how to do OSGi, how to create bundles, how to write your manifests and stuff like that. And later on we will start talking about more, enterprise-y APIs. And when we start talking about that more enterprise APIs, we're going to a database, we're going to do some RESTful web services and stuff like that, and then I'm going to go back to the application and add that to it. So let's get started and move to Eclipse. So what I have here is Eclipse, and I have one plugin installed, which is the B&D Tools plugin. And B&D Tools is just focused on doing application development with OSGi. And it's by far the most easy way to do so. If you're going to do OSGi, please take a look at B&D Tools and don't try to, do it on your own or use Maven or stuff like that, because you're just going to have a much harder time. B&D Tools is around for more than a year now. It's very stable. The 2.0 version is almost out. I'm running on one of the latest builds now. We are using it in production for over a year now, and it works great. So what I'm going to build is just a small conference application. So I'm going to build an agenda, and that agenda is just an overview of conferences coming up soon. And of course, we're just going to focus on modularity here. So the application itself is not going to be that interesting, functionally speaking, but it's more about the architecture of it. So when you start building applications like this, the first thing you have to think about is your APIs. Well, I just said I want to have something like an agenda, so that sounds like an interface. And an interface have to deal with conferences, so that sounds like a domain class I want to use. Let's start building something. What I'm going to do is just create a B&D Tools OSGi project. And I'm going to call it agenda. And because this is my first project, B&D Tools recognizes, well, you have created a B&D Tools project, but then you should also have what I call a CNF project. And I'm just going to create it and then explain what it is. If I take a look at the repositories view here, and apparently it takes a while to load it at the moment. It is downloading some stuff now. This is a repository. And in this repository, there are several of them. There's all kind of, frameworks and dependencies that I can use. You can compare this to a Maven repository. So a repository here is just a place, and it can be a place on your local file system or somewhere on the internet, or there are several implementations possible. And there are just jar files in there, and all those jar files are OSGi jar files. So they are bundles, which means it's just a jar file with a manifest in it. For the rest, it's basically just a normal Eclipse project, and I can start writing some code. Let's start with a class. And this is going to be my agenda.api package, and I'm going to add a conference type. And a conference should have a name, and a conference should have a location, with some getters and setters, maybe a toString. That's not what I intended. A constructor, and maybe a constructor with some fields. That's it. Just a normal class. And then we need an interface. An interface is going to be our agenda type, and it's going to be an interface of services we are going to create later. And it's going to be a very simple interface with just two methods. I want to have a method that returns a list of conferences. And I want to have a method that can add conferences to the agenda. There we go.
Could you make the text larger?
Yeah, I guess I can. Good enough? This is just some code. There's nothing OSGi related just yet. If you look at the generators folder here, BND Tools is generating a jar file for us as soon as we just save our code. So as soon as something gets compiled, we get a jar file. But this jar file is completely empty at this moment. You see there's no classes in it, there's no interface in it, and there is an empty manifest. Well, a manifest with nothing interesting in it at least. That's because we have to specify explicitly what kind of classes an interface should be public and what kind of class and interface should be private. This is a decision you have to think about. You don't just want to make everything public, because that's breaking modularity from step one then. And of course you don't want to make everything private, because then I actually can't use this interface. In this case I'm going to add another kind of file, which is a bundle descriptor, and in there I'm going to define those exports and imports. And this is going to be my agenda.api, so I just call it API. And BND Tools has some nice wizards for this. And well, this is just the overview of what I want to have in my manifest. And from here I can just drag my API package and say, well, this is going to be an exported public package. It gives a version, and well, later on this will help me with semantic versioning, so that I can see when I'm breaking interfaces, for example. And I save that. Take a look again at my agenda jar file. You see the classes are here now, and more interestingly, in my manifest there's an export package of the API package together with the version. That's it. This is my first OSGi bundle, and I didn't really feel like it's a lot of work or it's very difficult so far. So this was easy enough. The only extra step compared to, well, normal Java development is that I had to actually export that package. That's the only extra step. But this is just an API. Just an API is not very useful, so we have to have an implementation of this API. And what Bert just talked about is that we need something that implements it, and that we can register to some kind of service registry. Well, OSGi is a mechanism for this, which are OSGi services. And OSGi services can be registered to the OSGi service registry, and other parts of your application can look up something in the OSGi service registry and start using it. And when I start talking about OSGi services, well, people say, well, please don't go there, because we already had this hard time with imports and exports and OSGi services. Well, they're way more complex than that, and I have to think about, thread safeness when I'm going to register and look up stuff, which is difficult. And, well, it's just a lot of work in general, and I have to think about service dynamics and everything. And that's all true. Conceptually, this can be complex. But in practice, if you use the right tools and you use the right frameworks, most complicated stuff is taken care of it for you. So it's really not that hard to use. So the first thing I'm going to do now is just implement an OSGi service and register that to the service registry. I have one more choice to make now. In BND Tools I can decide, well, I'm just going to create another project for my next bundle, because my service implementation is going to be in another bundle, so that I can have several implementations in several different bundles for my agenda interface. And in BND Tools I can say, well, I create an Eclipse project per bundle. That's fine. Or I can say, well, I'm using one Eclipse project, but I'm going to generate multiple bundles from this one Eclipse project. The best practice here is, well, if you have stuff that's functionally very, very much related, most of the time the dependencies you're using within that project are also, well, more or less the same for the projects you're using there. In that case, it's most easy, most convenient to just put them in one Eclipse project, but generate several bundles from it. So your development view is a little bit different than your deployment view, which is fine. So I'm just going to go for the easy way here, and I'm going to say, well, first of all, I'm going to add another bundle descriptor, which is going to give me another bundle. And I'm going to call it service.simple. And you see immediately here, there's another jar file generated, which is still empty because I didn't have any code in it yet, which is called agenda service.simple.jar. So let's add more code. There's just going to be a class file, agenda.service.simple, and it's going to be my simple agenda service. Going to implement the agenda interface. Well, it's a simple agenda service, so I'm just going to store my conferences in memory for the moment. There's going to be a list of conference. And it's just going to be thread safe array list. Here I can just return the conferences. And in this method, I'm just going to add a conference to the list of conferences. Okay, great. This is just a POJO. That's good. But now we have to deal with all that complicated stuff with registering this to the service registry, making sure we work correctly with service dynamics and everything. So how do we do that? Well, it's actually very easy. I'm going to use a framework for that. The first thing that I'm going to do is add another class, and that new class is going to be my activator. And an activator in OSGi is a class that's going to be called by the runtime when this bundle is started. And it just has a stop and a start method, basically. But I don't want to use the low-level OSGi APIs here, because then I have to think about, well, those low-level service APIs, and then I have to deal with thread safeness and everything myself, which is, well, a lot of work at least. And you should only do that when you're creating very low-level OSGi frameworks yourself. As for just writing application code, I'm not going to do that. I'm going to use a framework. The important thing to remember here is that there's a lot of different frameworks which do dependency injection in slightly different ways. So they all build on top of the low-level service APIs from OSGi, but they do that in, well, different ways. You can use annotations, you can use XML if you would really want to do that. You could use Java API, which I'm going to do today. There are many different ways. They all do the same thing. You can even combine them in one application if you would want to, because they are all based on the service registry. But you should pick one of those frameworks to do the hard work for you. Don't do this by yourself. Because I want to start using a framework, and in this case I'm going to use the Felix Dependency Manager, which is one of the dependency injection frameworks, you first have to add that to your build path. And for that, I'm going to my BND file. And the build path is basically the classes which are on your build path from Eclipse. This doesn't mean that I'm using all of them. This doesn't really affect my package imports either. This is just what Eclipse sees and makes available for me. So I'm going here and I'm going to get an overview of all the stuff that's in my repository at this moment. And I'm going to look for the dependency manager. And it's not there yet. It is correct because in the default generated repository from BND tools, the Felix dependency manager is not there. So we have to put some new dependencies, which I downloaded, and we have to put it in a repository. Well, we probably all know how to do this in Maven, but I don't want to use Maven, so I'm going to do it in a different way. And I've got this prepared a little bit to speed things up. I've got a whole directory full of bundles, and later on I'm going to use all of them. For now, I'm just going to drag all of them into Eclipse, and when I start using them, I will explain what they actually are. But for now, I just pick them up and drag them to my local repository, which is just a directory on my file system. BND tool sees that they're all OSGi bundles, which is great. They all are versioned, so I can just start using those. Now I can go back. Now I can go back to my build path. It's kind of slow because it's doing lookups online in some online repositories all the time, and the network isn't that great, apparently. But we have the Felix dependency manager now. I'm just going to add that to my build path. And now I can go back to my activator and say, well, this is going to be an extension of dependency activator base. It's just a base class which will do all the hard service work for me. And I forgot something because I need one more API. If I can. The The Felix Dependency Manager internally uses the low-level OSGi API, so I actually have to add that to my build path. It should take like a second. So I want to have the OSGi companion bundle for later use and the core bundle, which is just all interfaces. There's no implementations in there. And now I've got an init and a destroy method. The init method is called by the OSGi runtime as soon as my bundle gets started, and the destroy method when the bundle gets stopped. And in this case, we only need to deal with the init method. So I've got my dependency manager here, which I'm going to use to register something to the service registry. So I'm going to say manager.add. Remember, this is a Java API. I could do the same using annotations or XML if I would want to. And I can say, well, I'm going to create a component, and this component has an interface. And this is my service interface. So that's going to be agenda.class, has to be a string, so agenda.class.getName. I can add service properties. I will get back to that later. For now, it's just null. And I have to specify my implementation. And my implementation is the simple agenda service.class. Screen is a bit small. There we go. That's it. We're done. This is registering something to the service registry. Well, that's really not harder than using any kind of dependency injection framework, to my opinion. I want to add one more method to my simple agenda service implementation because I actually want to, test something. So for now, I want to have a method that gets executed when the bundle is started, so I can add some conferences to the list for testing. So let's just add a public void start method. This is recognized by Felix Dependency Manager automatically and will be called unbundle startup. So I'm going to say conferences.add new conference. And this is Java 1 in San Francisco. And we also have DevOps coming up in Antwerp. And this method is just going to be called automatically because I use Felix Dependency Manager. Remember that I didn't put this code to any bundle yet. So my generated service.simple bundle is still empty. You'll also see this on this little icon here. This code is just sitting there and doing nothing. So let's open my BND file again, drag this stuff, and in this case I'm just going to drag it to my private packages. The OSGi runtime does have access to the private packages and can call the activator. I do have to specify it here though. And the only thing the activator does is register, an implementation class, which should be hidden, should be private. But it will publish it to the service registry using my public interface, and other classes, other services can inject that implementation just using the service interface. And we have our modular approach working. Let's take one more look at a jar file. The code is here now. That's correct. And we have a manifest file. And what we see here, we have a private package. There's nothing exported, so this just doesn't contain any public code. And another interesting thing is that I have some import packages here. On the picture Bert showed earlier, we saw that when I'm using some public code from other bundles, I have to make this very explicit. This bundle explicitly says that it requires agenda.api and requires the Felix Dependency Manager. These are packages that must be exported by other bundles. If I deploy this to an OSGi runtime and those other bundles are not there, the OSGi runtime will tell me. And it will tell me this bundle cannot be started because those dependencies are not there yet. And this helps you a lot when doing deployments because, you can just see that you didn't deploy everything yet, and you will not just get random class not found exceptions during runtime. This will make sure that all the classes that you require are actually there. bundle starts, all the code is there. Okay, so we have our service implementation ready, but now of course it would be nice to actually run it and test it. So let's create one more bundle. This bundle is going to be the client of the service. It's going to use the agenda service. And let's start simple and say it's going to use it on the console. So it's just going to be a console client to work with my conference schedule. Later on we will add a REST service on top of it. So I'm going to create another package with another class in it. It's going to be the agenda.console. And what I want to do here is, actually use my agenda. So this is going to use my service implementation that I created earlier. And I want the framework to actually inject that for me. So here I'm just going to define that I have this dependency. It's going to be an agenda. I don't really care what kind of implementation of agenda, I just want an agenda. And it's going to be volatile, that's just something you should do, because there can be several threads working on this code, and at some point, my agenda service can disappear. I will show that in action later on, and that can lead to readability problems. So it should just always be volatile. And let's say we start just with a start method like we did earlier, and when this bundle gets started, I want to use my agenda service, get a list of all my conferences, and just print each conference. Good enough. Because I want to use my agenda service, I have to inject it somehow. Or I could look it up by hand, but then I'm using low-level APIs, which is complicated again. So once again, I'm going to use the Felix Dependency Manager. And this console is actually also going to be a service. It's not going to be published with a public API, so nobody is going to use this service as a service, but technically speaking, it is a service. So I'm going to create another activator. Remember, this is a different bundle, so I can't just reuse the activator that I already had. And once again, it's going to be the dependency manager activator base. Start the same. Manager.add a new component. Create components. Set interface. In this case, I'm going to do something interesting because I'm going to say it's going to be an object, which basically means, I don't really want to use a public interface, so I'm just going to specify objects, which basically means, nobody should use it. I'm not going to care about service properties again. My implementation is going to be my console agenda.class. And now I have to do one more step, which is injecting my agenda service. So I'm going to add one, create service dependency, and I have to specify the service that I want to inject, which is the agenda.class. And of course, nowhere I'm specifying what kind of implementation I want. I'm not going to talk about my simple agenda service. Even if I wanted to, I couldn't, because it's not exported, so it's not visible in this bundle. I just have this interface. Once again, I have to specify that I want to create a separate bundle for this. This is going to be my console bundle. Drag my console package as a private package. Specify the activator again. And there we have it. So I've got my public API bundle. I've got my simple agenda service implementation. And I've got a client for my agenda service, which is a console application. And now we have to start up an OSGi framework and start running those bundles. Well, BND Tools makes that very easy also. You can just go to a run configuration, which is part of the BND configuration, or I can specify them in separate files if I would want to. And I have to specify what kind of requirements I need on runtime, which basically means what bundles should be deployed to the OSGi runtime, which are part of my application. Automatically, it will already add the projects that I have here. I first have to specify what kind of OSGi framework I want to use. I use the Felix implementation on Java 7. Every time I'm going to run this wizard, it's going to go online, so that's kind of annoying. Okay, let's start very simple. I'm just going to add one, resolve the rest automatically. I have my imports specified anyway, so most of the stuff can be figured out by BND Tools itself. I'm going to save it, and I'm going to run it. Nothing much is going to happen, but I'm showing you this for a reason. So open a console. What you see here is that, well, basically nothing happened. The application is still running. There is an OSGi framework active. It is running, but I can't interact with it. I didn't specify that I want to start an OSGi console or anything like that. My code is working, but, well, it's just sitting there doing nothing. So let's make it a little bit more interesting. I just keep my application running, but I'm going to go back to my wizard here.
Can I ask a question?
Sure.
So,
If I would know where you are.
Like 2 bundles, right?
3, yeah.
3?
Yes. API, console, and service implementation.
Okay. So the console had this private volatile, instance that was going to get injected.
Yeah.
Did that happen by class type?
Well, I specify the interface, so that's it.
So when you say run and you've included these Felix dependencies, then they're going to figure out what to inject?
I specified I want to have some kind of agenda implementation. And at this moment, there's only one. So as soon as the agenda service implementation gets started, when that bundle gets started, the implementation will get registered to the service registry. And at that moment, the dependency injection framework will say, oh, I've got an implementation. And on the other end, I've got someone who wants an implementation, so just inject it. I'm going to show a lot about the service dynamics in just a few minutes, so sit tight and...
What's going to happen if there would be more than one implementation? How you can specify what?
Excellent question. I'm going to show you a lot about that.
Could you repeat the question, please?
Yes, I will. He asked me what happens if there are multiple implementations of a bundle. I will try to remember the question next time, or repeat it. So I'm going to add 3 more bundles, which is the GoGo shell. The GoGo shell is one of the OSGi shells available, and that gives me just a nice way to play around with the framework a little bit, start bundles, stop bundles, etc. Which is not something that should be used for, end-user console interfaces. This is just some management stuff that you can use. But now it gives us a nice way to play around with the framework a little bit. So I'm going to save this. And immediately, in our running application, we've got a console. Sorry. And that's the nice thing about working with OSGi this way. Everything gets just loaded with hot deployments. So I added some new bundles, and they just get started, and I can start working with them. You never have to restart your application at all. It just all works dynamically. So what can we do here? We can, for example, say, give me a list of all the bundles. And we see, we have some Felix dependencies. We have those because we have the Felix dependency manager. I've got my API package, I've got my console, and I've got my simple implementation. And I've got 3 GoGo bundles that give me the shell. And all the bundles are active. And active means all the imports that I have defined in my manifest are resolved, which means they are there. I didn't have any missing dependencies. If there is missing dependencies, you will see the state on installed, which means, well, this bundle is installed, but it doesn't do anything. The code is not being activated because there are still missing dependencies. But if I would want to, I could also say, well, I'm just going to stop part of my application. So I get my service ID, which is 6 for the console, and I'm just going to stop my console. You see it's resolved now, which means stopped. And I can start it again. And then we see the start method is executed again. And apparently my service injection worked because I get a list of conferences here. Another interesting question is, what happens if I start my console bundle, but the service isn't there? So let's try to stop bundle 7, which is the simple agenda bundle. So I'm going to stop 7. I'm going to stop 6, which is the console, and I'm going to start 6. Well, in this case, nothing happens. Which, well, can be right because, well, my service isn't there anymore. And, well, apparently, at that moment, my code, the other code also just doesn't do anything. Well, let's take a better look at that. So we're going to go back to my console, take a look at the activator. This is kind of annoying. Take a look at the activator. And I'm actually kind of surprised that this works because I would expect actually a null pointer exception. Because here I'm going to iterate over a list of conferences given by my agenda. But if my agenda isn't there, well, this should give a null pointer, I would say.
According to the Felix docs, it injects a null object, because I was wondering the same thing. That just doesn't do anything.
Right, but if I do call list conferences on it, and then I iterate over the result of that, this would be null, and this should give me a null pointer exception.
Yeah, that's true.
So I have no idea why this doesn't give me a null pointer exception. Which is probably good, but anyway, let's continue and we will get to that null pointer exception at some point, I'm sure. It's not that convenient to well, just keep on stopping and starting my bundle all the time. So let's say that we're going to enhance the console a little bit, and we're going to make this a true console command. So I'm going to implement it that way that I can use it from the command or from the shell, just the way that I did stop and start methods, etc. I can type help here, and I get a whole list of all kind of commands. And I just want to have a command to list conferences, and I want to have another command to add conferences. Once again, this is not for end user interfaces, just to play around a little bit now, just to make the demo a little bit more easy. So right here I'm going to say this is not going to be a start method anymore, but this is going to be a list conferences. And I'm going to add another method, add conference, with a string name and a string place. And I'm going to say I've got my agenda, and I'm going to add a new conference based on the name and place. To make sure that this actually gets becomes a console command, I have to go back to my activator. This is the way the GoGo shell works. And define a properties object. And now I'm going to use the service properties to say, well, this is not just any kind of service, but this is a service with some, well, specific things on it, some specific properties on it. And the GoGo shell will pick those properties up. It will see, well, there's a new service registered. It has some properties which are interesting to me, so let's do something special with it. And to actually do so, I need one more dependency on my build path. run. And it's going to be the GoGo runtime. Go back to my activator. And in this properties object, I'm going to put a command processor dot command scope. That's the key. The command scope, well, that's the group of functions that I'm going to define. I'm going to call this agenda. And I have to specify the methods that I actually want to use. It's going to be command function. This can be a string array. And now I have to use the names. It's not type safe in this case, but that that gives me the nice thing that the implementation of my commands don't have to use any kind of API specifically for GoGo. And I have the list conferences method, and I've got the add conference method. And I'm going to pass this properties object as the service properties to my service. Let's check if it worked. I type help again. And I've got two new commands without starting my framework again. So this is a nice development experience. And let's see if it works. List conferences. And I finally get my null pointer exception. Excellent. Let's start my agenda service again. I will get back to the service dynamics in a moment. And let's try again. If I can actually spell it. There we go. So, looking back at this null pointer exception, why did that happen exactly? Well, the way the Felix dependency manager works, and this can be different for different implementations of dependency injection frameworks, so you have to know about your specific implementation. But the way Felix dependency manager works is say, by default, a service dependency is not required. And when it's not required, when I call any kind of method on it, it will just do nothing. It will just return null if it needs to return something, and that's it. So in this case, this call is going to be okay. It's not going to throw any kind of null pointer exception. This agenda is going to be a proxy which just always returns null. The problem is in this part. I'm going to iterate over a null reference, which is not going to work, and that's going to throw the null pointer exception. So the solution here, one of the solutions here, is just check if this stuff is null, and else I'm just going to tell the user that the agenda is not available. Let's go back to the console, if I could find it. So let's try again. The service is still here, so that should still work. But I'm going to stop bundle 7, which is my agenda service implementation. Try again. Agenda is not available. Well, it's not there, so I just handle that from code now. That's one of my options. Start it again. And try again. And so I can deal with a service being there at one point and not being there at another point. So you could ask yourself, why would it happen? Because now I'm just playing with my console and stopping bundles, starting bundles, and why would I do that in real life? Well, this can happen in real life. We have talked about modular deployments, for example. What if I have my application running in the cloud and I want to do some small updates to it? Does it make sense to just take it offline and deploy everything again, maybe a very big WAR file or something like that, and start everything again? Then I have downtime. I have to start dealing with that in some other way. Why couldn't I just upload my new implementation of the agenda service, for example, maybe some parts of my application should, degrade a little bit. In this case, at some point, my agenda service will be updated, so it will go offline first. If someone uses the agenda service, it will say, it's not available at this moment, but the rest of my application can continue to work. And as soon as the bundle is updated again, it will be started and will be available again. So this way I can actually deal myself with doing hot deployments, instead of just taking everything down, reinstalling everything, and starting everything and hoping it works. The other thing you could say is, that's all nice and everything, but it's going to be a lot of work. Because if I would have to write my code in this way, with null checks everywhere where I use a service, that's going to be a lot of work. And in many cases, it doesn't make sense to deal with it. Because in some cases, I just can't do anything useful if my service dependency is not there. In this case, it makes a lot of sense, because, I want to actually tell the user something is not available. And in some other cases, what can I do about it? What can I do about, maybe a REST interface being having a dependency on some kind of data service that returns something from a Mongo database, for example. If my Mongo service isn't there, what kind of data should I return to the user? It doesn't really make sense to even start that service. And then it would be a waste of my energy to just add null checks everywhere. So there's another option, and I'm going to show you that. When I define a service dependency, I can also say if it's required or not. And by default it's not, then I have to handle it myself, but I can specify it's required. What happens now is whenever my agenda service is not available, my console application is also just not going to be available. It's just going to be down and it's not going to be there. The service is just going to be deregistered automatically. And as soon as my agenda service comes back up, my console is going to be there again also. And this is all handled by the dependency injection framework. So let's try that out. Somehow I have a hard time finding my console every time. So in this case, remember it's required. So let's check if it's still up, still there. Now I'm going to stop the agenda implementation. Let's start with the help, see if my command is still there, and it's not. My whole console command has just, disappeared. In this case, I would say, this is not the best solution because, it's kind of weird if your command is just gone at some point. But you can see, how you can use this in an effective way to just make your life a lot easier because, if dependency is not there, I'm not going to be there, and I don't have to do any null checks at all either, because I'm just not going to be there. And of course, if I start it again, I can play with it again. To my opinion, besides that, the way I write it is maybe a little bit different, but to my opinion, this is nothing more difficult than using any kind of other dependency injection solution. This is very similar to the way CDI works. You can compare the service registry with the bean manager. It's very similar to how Spring works. Also Spring as something like a bean manager. You just register something some way in the service registry, and you use a framework to look up services from there and inject those. But what we did get in this case is first of all we have several bundles. So we have the dependency, the modularity nailed down, and we're using dynamic services, which gives us a lot of flexibility later on when we start deploying stuff and maybe start playing with multiple implementations of a service. Last thing I want to show before we move on to more enterprisey stuff. There's also a lot of OSGi services already available on the internet, and a lot of them are also specified in specifications. So there's the OSGi compendium specification, which defines a lot of interfaces for services that you would often need in any kind of application. And probably the best known example of that is a logging service. So for example, to my agenda service implementation, I want to start logging whenever I add a conference. So let's start using that interface. I already had it on my class pod. My log service. It's going to be injected, so it has to be volatile. And this just works like any kind of logging framework. Besides that, this is based on OSGi services. Just print something. And of course I have to add it as a service dependency. And a log service is typically something that should not be required, because my code can work perfectly well without my logging service being there. Well, it can be executed and it will just do nothing whenever it's not available. But of course in production I would want to install it, and that would just mean I have to install the log service bundle. I'm actually not sure if it's already here, and it is. Yes?
Is it required to each and every time add new dependency in the code, or is it possible to do some kind of declaratively in some manifest or something like that?
In Felix Dependency Manager, as is, this is the API, just a Java API, which some people like. I like it, some other people don't like it. There's another framework on top of it which adds dependency annotations. So then you can just use annotations like you would do in CDI, for example, and those will be picked up by the framework. Then you don't use a Java API anymore. You don't actually have to write an activator at all anymore. There's other kind of frameworks. Some of them use annotations as well. There's even a port of CDI going on at this moment. It's being standardized. So then you can use CDI annotations to work with your services and your dependencies. There's other frameworks that use XML, so there's plenty of solutions. Just whatever you prefer. I think for the first steps of the demo, we're about done. So let's start talking about more enterprisey stuff.
So what we've seen up until now is that how we chunk up our application design into more functionally coupled modules, right? So we have like a separate API part, we have a separate implementation part, we have a separate client part, and then while we have it at design time, we also had it at runtime when Paul configured the run configuration, and we had the dynamic services nature using OSGi in order to cope with services being there and services being instantiated. So the next thing is, after we got the basic stuff done, how can we reuse all of the enterprise stuff, which is already available? Like in the past 10 years, we've been building Java EE applications, or you've been using Spring or other frameworks in order to build those kind of applications. And how can we use the power of both worlds, right? So at first you think, well, OSGi is kind of the low-level stuff, and you have to do everything yourself, right? So it's in the bottom right-hand corner over there. And on the other hand, we have Java EE, which is known for its high-level APIs, so this will probably not work together, right? And in the past couple of years, I think that was exactly the case. So the EE world was completely agnostic of the OSGi world, and the other way around as well. So OSGi had nothing to do with EE. But things are changing right now, so they don't have to be either or anymore, and that's exactly what we're going to show you. So how can we combine those two initially separate worlds together? Well, we think that you have three options of dealing with combining those two worlds. And I just want to briefly mention them, and then we will dive into all of those three. The first thing is what we like to call OSGi as your core architecture. So you will use the OSGi container as your core container architecture. And then there are implementations which publish the separate EE APIs, just like OSGi services in that OSGi container. And this is exactly like a number of application servers are doing it today. For example, the Glassfish application server is essentially an OSGi container which publishes the EE APIs as OSGi services. So you can just register your own OSGi services in the OSGi container of Glassfish, and you can start mixing all of the services together. So this is your first option. We will talk a little bit about it more later on. The second option that you have is what I like to call the hybrid solution. So you have like an application which essentially has two goals. One of the goals of your application is being like an administrative part. So it has like CRUD functionality, you know, updating stuff in a database, reading stuff from the database, deleting stuff, etc. So it's like more of a boring administrative stuff if you want. And then another part of your application has to deal with runtime dynamics, because it has like a lot of external interfaces which may be there at some point, which may not be there at another point in time. Or they have interfaces which break a lot, for example, because the other parties that you're dealing with, they just, well, randomly change their interface for some stupid reason, right? Sometimes you have to deal with that. And if you have such an application and you don't want your application to be down as soon as that happens, then OSGi might be an excellent solution to deal with with that complexity. So if you have an application which has those two sides, then you're looking for a solution which has Java EE on the one side and OSGi on the other side. And you have to combine them using what I like to call an injection bridge. And we'll show you some examples of how to do that later on. And then the third option that you have is like OSGi a la carte, which is a plain OSGi container. Actually, it's what Paul just showed you. It's a plain OSGi container, and you just add dependencies to it as you go, right? So you don't need an entire application server, but you just start with an OSGi container, and as soon as you need, for example, some RESTful stuff, or if you need some JPA stuff, you just add like an OSGi-ified version of your JPA API to your OSGi container, and then you build up your development platform as you go. So essentially, number 3 is like a variant of number 1, so to say. So let's look in some more detail to those 3 options. You want to talk about the first option?
Yep. So this is something happening, started recently actually. My Microsoft, why? Am I on again? No. Am I on again? Great, thanks. So this is something that started recently. What you see is that application server vendors started building their application servers on top of OSGi in the last few years. So most of the application servers out there today, including Glassfish, for example, and WebSphere, are built on top of OSGi. Well, that's great for the people working on that, but that doesn't really help you anything, besides that it might be starting faster than before. But what has been happening in the last 2 years or so is that the APIs available in those application servers are going to be exposed to application developers using OSGi services. Well, let's give an example. Let's take the Glassfish application server. The Glassfish application server is essentially just a Felix OSGi container. That's it. The runtime is just Apache Felix. On top of Apache Felix, they implemented all their Java EE stuff, the EGB container, servlet container, JAX-RS container, CDI container, etc., etc., etc. All of those things are just OSGi bundles implemented as OSGi services. So the OSGi or the EGB container is actually just a bunch of OSGi services. So far you didn't really see that as an application developer. That was just the way Glassfish was implemented, internally. What they started doing recently is expose those APIs, those Java EE APIs, so for example the EGB API and the JPA API, they started exposing those APIs as OSGi services. You can actually deploy OSGi bundles, within Glassfish application server like you would normally. And then you can just, use an OSGi shell, which is already installed by default in Glassfish, to just see all the list of bundles, and you see your bundle next to the, EGB bundle, for example, which is just the EGB container itself. In that way, you can, use the enterprise Java APIs as OSGi services. So on one hand you get the modularity like I've shown you just now, you just create bundles, that's it. But you can inject references of OSGi services to, for example, the EGB APIs, to JAX-RS APIs, etc. So you get a programming model of Java EE in a modular world. Sounds kind of perfect. So let's give some examples of code. And this is stuff that actually works. In OSGi there was a standard defined in the enterprise OSGi specifications, which are the web application bundles. Now, web application bundle is basically just a WAR file, like we know, but added on top of that there's a manifest. And the manifest contains the imports and exports and the name of the bundle and etc. For the rest, it's just a normal WAR file. within that var file, I can add servlets and JAX-RS components, use annotations on top of those, and they will be picked up automatically by the application server if my application server supports it. So for example, I've got a JAX-RS resource in the bottom, and it contains an annotation. I don't have to add any activators or stuff like that. This is just plain Java-E. I package this in a jar file or a var file. Extension doesn't really matter. And the only thing special about this var file is that there's one more file, which is the manifest.mf, which is my OSGi manifest file. And in there I say, well, this bundle has a name, and it has some import packages. And besides that, there's one new construct there, which is the web context path. And this is the context path where this JAX-RS servlet will be listening. So in the end, I can request this using the URL /myweb/agenda. And that will be my JAX-RS resource. I can deploy this to Glassfish. This also works in JBoss, for example. And well, on one end, I just write my Java code like I would do normally. But on the other end, there are still bundles. I still can use all the nice things about service dynamics, because it is just OSGi services that I'm doing here. Just, well, a more convenient way to write them, you could say. So this is something nice. Something else is supporting Glassfish. This is not standardized yet. It is being standardized at the moment, though. And that's packaging EGBs within, well, an OSGi bundle again. So I have just a plain OSGi bundle. I have some code in it, but in that code I use some EGB annotations. Those EGB annotations give me nice things like JPA integration and declarative transactions. The nice things about EGB. And if I'm doing something with JPA, well, this helps me a lot. It's a lot easier than doing this by hand. And I can just package my EGBs in a OSGi bundle, deploy them to Glassfish. They will be actually registered as OSGi services, but I get all those enhanced functionality from the EGB specification. So this is just really a mixed world between OSGi with all the modularity things and the service dynamics on one hand, and the high-level APIs of Java on the other hand. This could be an example of an EGB bundle. I just write my EGBs as I would do normally. I add a manifest which says, well, export all the EGBs, and all those EGBs will be exported as OSGi services. So if I do a lookup in the OSGi service registry, I'll actually find an agenda storage service, which is actually an EGB, but I don't even have to know about this. So I can start using this EGB service from another bundle, which is just a plain OSGi service. Really combining best of two worlds. Another thing that's being specified at this moment is CDI integration. So all the things I did just now with Felix Dependency Manager, you could also do using CDI annotations, which is the dependency injection solution in Java now, which is very nice, has some very powerful annotations also. And well, very soon you can start using that to either register services or lookup services, or even do some things like messaging. The specification is still in development. The prototype is already working in Weld, which is the JBoss implementation of CDI, and also the reference implementation. So, well, probably very soon you can start using this in production. So how are app servers doing with this OSGi and Java integration? Well, if you look at the major application servers, you can see that most application servers already support deploying plain OSGi bundles. So I can deploy my OSGi bundles, register services and everything like that, because there is an OSGi runtime within those application servers. That doesn't mean, however, that I can also use JPA and EGB and stuff like that from my bundles. If you look to the next column, most application servers also have the Web Archive bundle support. So those var files with an extra manifest in it. Actually, every application server besides WebLogic at this moment. WebLogic will have this at some point. They already demoed this a few years ago, so they are working on it, but it's just officially not supported at this moment. If you look at EGB and JPA support, Well, it's not that great yet because there's no standard yet. There's no specification yet. But both Glassfish and WebSphere do have support for it. JBoss is working on it at the moment to use either EGB or JPA in a very convenient and easy way from OSGi bundles. The only problem is, they're doing it in slightly different ways because there is no standard yet. They're still working on that. But if you don't have to be portable over application servers, you can start using this.
That brings us to the second option, which is the hybrid solution I already talked a little bit about. So in this case, we have like best of both worlds. So we have a large part of our application which is just plain administration. And we know how to do that using Java-E because we've been doing so in the past 5 or 10 years or so. And then there's this dynamic part of the application which has to do with some complex situations in which some of your external interfaces might be there at some point and may not be there at another point, or they have like breaking changes. So you have to deal with those. So in order to have such like a twofold approach, using both OSGi and Java-E at some point in the application, you have to glue them together at some point, right? So for that we use what we call an injection bridge. And the injection bridge is, I can easily demonstrate it to you with a very simple code example. So at the bottom part of the screen here, there is a very simple servlet, just to demonstrate some Java-E resource to you. The servlet has a do-get method in which it will use an OSGi component, and it does so by using dependency injection. So let's take a look at the OSGi component first, which is on the top right part of the screen. Here you also see the dependency injection in action in order to register services. So we have an add component on top of a hello service implementation, which does something like printing hello to a logger, and which is not very interesting, but just to show you how it works. So we don't have an activator class here. We're just using the dependency injection framework here. And so this defines an OSGi service. The service itself has another service dependency. It uses the log service. So this is using some basic OSGi functionality. And then going back to the servlet again, we see that we can inject the bundle context in the servlet by using an add resource annotation, which is one of the annotations that come with Java-E. So we inject the bundle context, the OSGi bundle context, and the bundle context will give us actually a pointer to the service registry, and then we can start asking the service registry for a service reference by the name of the interface class. So for example, we can say get service reference of hello service.class.getName, which is the interface which is implemented by our OSGi service on top, right? So please don't use this code in production. This is a very, very simple example of how you could use both worlds together. But I think you get the point if you take a look at this simple example of how you can mix both of those worlds together. And at some point in your application, you have this injection bridge where you inject components from the other side. Right? So this brings us to the third option. So mixing actually up the or building our OSGi stack a la carte. There's a question. Yeah. Okay. So the question is, what about versions of the application server? Yeah. So the code I just showed you, this is code that works with JBoss AS7. So that's the latest version of the application server. And so if you want to use this, you need to have a AS7 for that. Yes. Okay, so the question is, do you know about a way of making this work in JBoss 5, right? So,
no, it's not possible.
No, not possible, unfortunately.
No. There's no OSGi runtime in 5. They added this in 7. So.
Yeah. Another question?
Yes. Now you have two different cores, as you call them, right? How do you manage the class graph loading and hiding of the implementations between these two different codes now? Because this the second one at the bottom knows nothing about the OSGi, right?
Yeah. Yes. So
It's
the
going to see all the classes there, right? And it's going to see all the services. You can't hide them, and you might have class loading issues, right? If you have like similar classes in both, and, you know, like they depend on something, both of them, some jar. You can't hide these implementations.
Okay. So the question is, how do you deal with class loading issues when you're mixing up both worlds? So the thing is, we have a number of deployables right here. So we have like all of the Java EE stuff, which might be in your regular WAR file. So you deploy everything of your Java EE part of your application in your WAR file. And then all of your OSGi components are still deployed in separate jar files. So if you have like a simple, just a single component like I have here, then it might be deployed in just a single jar file.
But they will see each other, right, in the class file?
Yes, they will see each other.
I think the important thing to point out there is that this is just, well, you could say a poor man's solution to going towards modularity. This is an option if you can't switch to OSGi completely and your application server doesn't support using OSGi, well, enterprise services from OSGi yet, then this could be a temporarily, well, migration step, you could say. But in the end, you want to have either option 1 that I just discussed or option 3 that I will discuss in a minute, and not this one.
Yes. So the important point to note here that this is not a true modular solution. I mean, this is just a way of dealing with like some of the things that modularity will solve for you if you have some difficult problems to deal with in part of your application. Right. Okay. Okay. So let's go to option 3, which is essentially OSGi a la carte, which is, well, creating your own development platform or creating your own application server, so to speak, by just adding just the libraries and frameworks that you need as you go. And the best way to illustrate this is just to do a demo again. So, Paul, if you want to.
So before we kick off the demo, the question is, why would you want to do this? Because, well, why not just use Glassfish or JWS or something like that if they have all those nice enterprise services? Well, for some applications, it just doesn't give you anything extra if you have EGB and JPA and JSF and stuff like that. In some applications it does, and then it's great. But for example, the application that I'm working on every day, well, we deploy in the cloud. We work with a lot of data. Relational databases are not an option for us, so we work with Mongo mostly. Well, Java doesn't really give us anything from Mongo. Well, we don't want to do anything like JSF or something like that. We just do client-side UIs. So, well, JSF, I don't want it, I don't need it, what does it give me? And so I have all my enterprise Java APIs and I just, well, don't need them. So in that case, why would I have the overhead of deploying them? Because they are taking space and they are taking memory, they are going to cost more time than starting up new instances in the cloud, for example, so that's just all overhead. In that case, it's better to say, well, I'm just going to start with the bare minimals and I'm going to add APIs that I actually need. And from Java EE, in this case, we only need JAX-RS. So that's what I'm going to do right now. We're just going to add some more APIs here and start to make this look a little bit more like an enterprise application. So the first thing that could be interesting is say, well, at this moment, my agenda service just stores stuff in memory. Well, that's not sounding really like an enterprise application. So let's start adding some stuff to Mongo instead. And for that, I'm just going to create a second implementation of the agenda service. And I'm going to show you how to, well, use them side by side. So let's create another service, agenda.service.mongo. Mongo agenda service. This is also going to be an implementation of agenda. And first of all, I need something to work with Mongo. Well, I could use the low-level Mongo APIs here because they are OSGi bundles already, but it would be much nicer if I can actually configure a Mongo service with a database and a username and stuff like that in it using a configuration file, and use that as an OSGi service. And for that, I'm going to use something from Amdatu, which is the stuff I'm working on. At home. It's an open source framework with, well, a lot of OSGi services and a lot of OSGi code that actually makes it easier to, well, create cloud-like applications, APIs that you need if you build that kind of applications. and Mongo is one of them. And first of all, I have to add it to my build path, which I didn't do yet. So this is going to give me two things. It's going to give me a way to work with Mongo as an OSGi service, and second of all, it gives me an object mapper, which gives me the possibility to just save conferences and look up conferences without doing the mapping myself.
What's that framework for again?
Amdato. I will give you a reference at the last slide to that. There's a lot of stuff in there. There's support for JAX-RS, so you can start to create JAX-RS services in a very OSGi-like way. I'm going to show that in a minute. Support for multi-tenancy, to do it in a very transparent way. There's support for Mongo, there's support for Cassandra, there's support for blob stores, all kind of stuff that you would need if you create this kind of, cloud applications. And besides that, there's a lot of deployment-related stuff. I need Jackson. That's my object mapper. And it gives me the MongoDB service. And from here I'm going to talk to Mongo by saying MongoDB service, give me the database. This is just a plain Mongo API. Please give me a collection. Collection is like a table, if you would compare it to a relational database. And instead of working with a low-level API, I'm going to wrap this collection in a Jackson DB collection, which uses the Jackson API to do object mapping. It's going to give back the conference type. And from there I can say, I have my conferences. I want to find all of them. I just want to do a select all, basically. This gives me a cursor. And with that cursor, I can iterate over all the rows in Mongo. And add them to a new list that I'm going to return. Going to be cursor.next. And you see I don't have to do any object mapping myself. That's all done for me. And in the save method, I'm just going to say that I want to have a Jackson DB collection again. Conferences.save. And that's it. This is going to be working with Mongo. Very easy. This MongoDB service is based on the concept of a managed service factory, which means in OSGi, I need some kind of configuration to actually start up this kind of services before I can inject them. So this service is not going to be there automatically, but I first have to tell in some configuration file what Mongo server I want to use, which username and password, etc. I want to use, and then there's going to be a service instantiated and will be injected into this service. Let's first finish this. I need another activator. It's going to be the dependency activator base again. From here I need my manager to add a component. It's going to be an agenda service again. My implementation is the Mongo agenda. And I have a service dependency on the MongoDB service. And that's going to be required because I can't do anything useful when Mongo is not there. Okay. Of course, we have to add this to a bundle. So we're going to drag the Mongo package to a private package and configure the activator. And immediately we see in the running framework, well, there's a problem now because I can't start that bundle. That bundle is added automatically to my run configuration because it's part of my project. But it was not started because I need some other dependencies which were not added automatically. Because, well, I have some imports on packages which are not in my runtime yet. So I have to go back to my run configuration. Yeah, there we go. So I had my Mongo bundles, just to make sure that I don't have to open this wizard again. I'm also going to add the injection bundles myself. Okay. Let's see what happens. I will start Mongo again. Works, doesn't give me a resolving error now, so all the dependencies are there. But if I start to list conferences, I still use my old service. This is not Mongo. I didn't put anything in Mongo yet, so, well, this is certainly not from Mongo. This is just my in-memory implementation. So, one of you guys asked me earlier, what happens if there are multiple implementations of the same service? Well, basically, by default, first come, first serve. So the first service that is registered will get injected whenever I do a lookup. Well, there are a lot of things I can do about this. First of all, of course, I can just say, well, I'm not going to start that bundle. That's the wrong bundle, by the way. I'm not going to start my simple agenda service. That's bundle 12. And just try list conferences again. And now this is interesting because apparently my agenda service is not there at all. My Mongo service didn't come up yet. Which is correct actually, because I forgot one step that I did talk about actually. I need a configuration file to actually, well, start working with Mongo. The Mongo service will not be there before I configure it. So let's add a configuration file. Got that one prepared already. This configuration file, if I'm allowed to open it, this configuration file uses the meta type standard, which is also an OSGi standard, and just a way to configure stuff. So let's say my database is called Java 1. It's running on localhost. I have it running already. And the important part is here. I have a factory PID, which is, the factory PID which is used in those Mongo code that says, well, if you find configuration with this PID, it's mine. Give me, and I will start services according to this configuration. Now I just need to add something to my run configuration to actually pick up this configuration file. I need some bundle to scan this load directory. Well, the Felix file install bundle can do that. There's many other ways I can use configuration nodes. I could use it from code, and I can use property files, etc. File install. And config admin, which is the implementation of, well, storing configuration, basically. Go back to my console. And I already see there's a new instance created with some cryptic ID. And now there should be a Mongo service. So if I start saying list conferences again, well, it doesn't return me anything because there's nothing in Mongo yet, but it is working again. So that service should be there. The other thing that no, let's skip that. So Mongo is there, so let's add something to it. Add conference JFall in the Netherlands. Let's switch to Mongo and see if it's actually there. Conferences.find, and JFall is there. So we have the connection with Mongo working. So we were talking about what happens if I have two implementations of a service interface. Because if I start my bundle 12 again, in this case we are still going to Mongo. This gives me an exception because I'm missing a field on my the ID field on my conference now. But well, now I'm always using the Mongo interface, and if I well stop that bundle, then I will start using the other one again. Well, we can try that. So let's see some hot switching of this. Agenda.mongo bundle 13, stop 13, list conferences. I'm switching back automatically to the other interface. So this is already something interesting. I can, well, basically hot switch between the implementations. And the other thing I could do is say, well, I'm going to my Mongo agenda service. No idea why I can't open code all the time. And actually I need an activator. I'm going to the activator and I'm going to add a service property which is going to be, well, a filter basically for injection. So let's try that. And let's say I want to say that this is persistent. Add it as service properties. And on the other side, in the console, I can define, well, I don't want just any kind of agenda implementation, but I want one specifically with the service filter, just using a syntax similar to LDAP. I can say persistent is true. And now I will only get injected the persistent agenda service and not the other one. So if I try this again, you will see, well, the Mongo service was stopped because I stopped it myself. The other service, well, is not allowable anymore because it doesn't have the service property persistent, and I can just filter it out. So that's another way, besides the type of the interface, that you can just select services, basically. So I have a lot of options here, and that makes it very powerful to also use in production. And if you use it in the right way, you can get zero downtime deployments. Last step for the demo, and that's going to be something related to REST services. So let's add one more class or one more bundle. This is going to be the conference resource. Go to the build path one more time. And once again, this takes forever. Just add JAX-RS. It's just the interface of JAX-RS like you would use in Java, exactly the same. And the way we're going to use it is also the same as in Java. I'm going to add path annotation. The way this works in OSGi is also something part of Amdatu. I'm going to say it has to listen on the agenda path. And I'm going to just add a method that returns a list of conference. It's going to be a get method that produces application JSON. Of course, it needs an agenda service. And here we can say return agenda.list conferences, and it will automatically be transformed to JSON. What?
Need to fix the conference model class with an ID.
Yes. This is something where, well, this is not really nice what I'm doing right now. Mongo requires me, that's just something in the mapping library, to have an ID field. I shouldn't actually put this right in my domain class, but this is breaking modularity because I'm binding to something, well, required by Mongo. Of course, I could do this in other ways, but well, we just don't have the time for it now. Okay, that's fixed. This is the JAX-RS resource. That's done. I just need to register it as an OSGi service so it can be picked up. That's going to be the activator. And for the last time, we say manager.add create component, set implementation interface is object.class because, well, this is going to be a REST endpoint. This is not going to be something that you should use as a Java interface. The implementation is going to be my conference resource.class, and we have a service dependency again on my agenda service. Agenda.class, which is going to be required. There we have it. Last bundle. With an activator. I need some new dependencies in my run configuration because I just added the interfaces so far. There's going to be some more Amdatu bundles. And I need Jetty because I need a web server now. Not exactly seeing what I want to see. What did I miss? Now I'm seeing what I want to see. Localhost, AD agenda. There we go. And we have just a JAX-RS resource implemented as an OSGi service. Okay, let's finish up. I think I've shown that it's really not that difficult to build modular applications if you use the right tools and the right frameworks. It's basically the same as doing, well, Java or something like that. And, well, actually, I'm going to finish up. What about deployment? Because now we have this nice modular application, and it would be a big waste if we say, well, we just package everything up in a big ER file and put it on our big application server. That doesn't make sense. What I want is modular deployments, just update the bundles that I actually updated. Maybe if I implement it correctly with 0 downtimes, and I want to deploy it in the cloud. And the way we're going to do that is using Apache Ace. Well, right after this talk, we're going to have another talk by Marcel. He is sitting right here in front, which is a colleague of mine. And he is going to talk about Apache Ace. So I'm not going to spend a lot of time on it. If you want to see that, he's going to talk about it. But to just pitch his session, I'm going to explain a little bit about what it is. Say we are running in the cloud, and we have our application running on, well, maybe 20, 30, 50 application servers, because we have a lot of different clients and we need a lot of load to handle. This is actually what I'm doing every day, basically on the architecture that I showed you just now. It wouldn't be a very nice job if you have to, well, if you update some code and then you have to update all your 50 application servers by hand, one by one. That just doesn't scale. And what we want to do is say, well, we have some provisioning server, which is Apache Ace. We're going to upload our updated bundles to Apache Ace, and Apache Ace is going to update all the application servers automatically. And a server, like you see on the right-hand side of the slide, well, it can be just any kind of OSGi framework with just one extra bundle installed in it. So that can be an OSGi framework like I was running just now. It can be a Glassfish installation. It could be some kind of device, maybe an Android device with OSGi running on it. It can be any kind of thing. And Ace just sits there in the middle, makes sure that all your servers gets updated as soon as you update your bundles. This is how it looks like. You update your bundles. You will see them as artifacts on the left-hand side. You group them into features and into distributions, and then you deploy them to a target. And a target again is well, anything that runs an OSGi framework. I can also use Ace to actually start up nodes in the cloud. So this can be used for using Amazon, for example. I can use this to start Amazon instances and automatically start using them without doing any installation myself, by just clicking. I can start an instance, register it as target automatically, and start deploying my OSGi bundles to it. And that's the way we can deploy in the cloud.
Okay, so let me do the final wrap-up. Just 1 or 2 slides. So what have we learned today? Well, first off, we have seen I think the way that we will be developing enterprise applications in the future, where modularity becomes more and more of an answer to the issues that we are facing. So you've got a glimpse of future enterprise development, in our opinion. I hope that we've convinced you why modularity is important, especially if you take a look at cloud applications. And well, I think what we showed you right now is how to do a practical solution if you want to do a real modular deployments right now. So if you want to do some more background reading about this, there's an excellent book about designing modular application architectures. It's the book on the left. And then if you start working with OSGi, at first you can just do it using all the basic stuff, and then eventually you will start to do more and more of the complex stuff as well. So the other book is an excellent background in all of the OSGi stuff. So these 2 books are recommended reading. If you want to know more about Apache Ace, of course there's a session by Marcel, I will pitch it to you in a second. Then if you want to know more about the Amdatu open source platform that Paul has been using in the demo, please take a look at amdatu.org. It will give you some more background, some tutorials, some articles about how to use it. You can download all the bits and play with it. If you start building your modular applications today, we highly recommend you use BND tools. So go to bndtools.org to download the Eclipse plugin. So you can use all of the wizards that Paul showed you. If you want to know more about us, luminous.eu is our company. So finally, if you want to see more, all about Apache Ace will be told by Marcel on 1 p.m. today in the Power Room. And just like Paul has taught you a number of times, the stuff that we have been showing you today is being used in production for real systems. So we have another session about that, or Paul and Marcel have a session about that, which is called OSGi in the Cloud, a case study, which will show you a real application in action using all of the stuff that we have shown you today.
That will also show you a lot more about automatic scaling and stuff like that we're doing very large deployments in the cloud.
Okay, so this is on Tuesday, 3 p.m., also in the same hotel in the Market Street room. So that's about it. So these are our coordinates. If you have any questions, we don't have much time left. I think 30 seconds or so. So if you have any questions, please come to us afterwards, after the session is closed, or reach out to us by email or via Twitter. Thank you.